Hello Year 3, here is your next science lesson. Over the last couple of weeks we've been looking at food groups and nutrition in foods, and we're going to step away from that now because our topic changes completely, and we're going to be looking at skeletons and muscles and how we move. Okay, so here comes the screen. Okay, so looking at types of skeleton, lots of animals there that we might be thinking about today. Okay, there's today's date and your Walt. So if you can write those in your books, just pause the recording while you do that. Okay, so the Walt today is to sort animals based on their skeleton. So we're going to be putting them into different groups depending on the type of skeleton that they have. And your steps to success, by the end, you should be able to name that there are 3 different types of skeleton, and you'll be able to say what's good and bad, the pros and cons of those different types. Okay, so here's a little discussion point to start with. There's a skeleton. What do you associate with the word skeleton? What does that make you think of? Maybe Halloween, maybe scary stories of spooky skeletons. But what really is a skeleton? Now, most of you will look at that picture there and realize that that is a human skeleton. That's what you look like inside your bodies. What is a skeleton made up of? Do you know what all of these are? All of these individual bits here? Yeah, those are bones. Okay, so this is a human skeleton, and it's made up of lots and lots of different bones. And today we'll be finding out about this type of skeleton that we have and other animals have, but also 2 other types of skeleton too. What's the job of a skeleton? What does it do? Where is your skeleton? If you have a look at your hands now in front of you, can you see your skeleton? So whereabouts in your body is it? And for some animals, their skeleton is in a completely different place. And some animals don't have a skeleton at all. Okay, so let's have a look at the next slide. Now, animals can be split into 2 big groups, and these 2 groups are called vertebrates and invertebrates. Can you see those words at the top of your screen? Vertebrates and invertebrates. And the difference between them is really simple. So on the left-hand side here, we have what a vertebrate is, and we are vertebrates. Okay, humans and lots of other animals are vertebrates, but there is a reason why we can put them into the vertebrate group. And the reason is because we have a backbone or a spine. Okay, if you feel down your back, you should be able to feel the bones of your spine. And that puts us as humans into the vertebrate group. Maybe you can already think about other animals which might also go into that group. So vertebrates have to have a backbone, they have to have bones, and all of those bones are actually inside our bodies. We'll come on to that in a moment. Now, this group here are the invertebrates. Can you have a think about what might go into that group and why they are invertebrates? Well, it's quite a simple one again. Invertebrates don't have a backbone, okay? They don't have bones inside their bodies. They don't have a spine. So we've got vertebrates and invertebrates. Vertebrates have got to have bones, a spine, a backbone, and invertebrates don't have a spine or a backbone. Okay, little test now, little quiz coming up. Okay, can you categorize? Okay, so these animals, could you put them into the vertebrates or the invertebrates group? Here they come. So vertebrate or invertebrate? A dog. What do you think? Vertebrate or invertebrate? Do you think a dog has got a skeleton inside its body? Has it got a backbone? Has it got a spine? Okay, if you've got a dog, and I know lots of you do, has it got a backbone? Can you feel a backbone inside its body? So vertebrate or invertebrate? I'm going to have to tick them for you, I'm afraid. So do we think vertebrate? Yes, it is. Okay, dogs have a skeleton. They have a backbone inside their body. What about a worm? Vertebrate or invertebrate? Okay, if you think about a worm, do you think it's got bones inside its body? Do you think it's got a spine, or is it quite a squishy type of animal? It's an invertebrate. Oh, sorry. Invertebrate, give ourselves a tick. No bones inside a worm. Okay, you've just seen the next one coming up. A dinosaur. Now, we know that dinosaurs are extinct, but they were once living animals. So would we class them as vertebrates or invertebrates? Can you remember from our rocks and soils topic, we looked at fossils, and we know that fossils are sometimes the bone remains or the hardened bone remains of dinosaurs. So they definitely had bones and backbones in their bodies. So they were vertebrates. Humans, we've already answered this one. Yeah, definitely got bones, definitely got a backbone. So we are vertebrates. What about a fish? Okay, sometimes you have fish, maybe for tea. What sometimes do you have to be very careful of? Yeah, the bones, and definitely fish are vertebrates. They have a backbone. Jellyfish, though. Anybody ever found a jellyfish in the sea or on the beach? Any bones in a jellyfish? No, definitely an invertebrate. Here's a tricky one. What about a butterfly? Think it's got any bones in its body? Vertebrate or invertebrate? It's an invertebrate. Oh, sorry, didn't tick it. There we go. It's an invertebrate. Okay, so we've now split animals into those two big groups, vertebrates and invertebrates. Now, vertebrates have something called an endoskeleton. An endo means inside, so an inside skeleton. And invertebrates can again be split into two more groups. And some invertebrates have what's called an exoskeleton. That means the skeleton is on the outside of their body. And the other invertebrate group have this very long word here, which is a hydrostatic skeleton. Okay, that means they don't have any skeleton at all inside or outside their body, but they do have some sort of fluid-filled compartments which give their bodies some shape and structure. We'll have a look at those on the next couple of slides. Okay, so this further classification, this grouping of skeletons from an animal depends on where the skeleton is. So all vertebrates have an endoskeleton. We have a skeleton inside our body. The endo means inside. And the invertebrates can be divided into two more groups. Exoskeletons, that means they have a hard outside of their body. And hydrostatic skeleton. Okay, so endo are the inside skeletons, exo, the outside skeletons, and hydrostatic. This bit hydro comes from water. So it's fluid-filled compartments. Let's have a closer look at those different types of skeleton. Okay, so endoskeletons. Animals with endoskeletons have skeletons on the inside of their bodies. And there's three examples there: an elephant, a human, and a mouse. Okay, one very large animal, one very small animal, and one a little bit in between. Okay, but they all have backbones, they all have bones inside their bodies. Endoskeletons are lighter than exoskeletons. And a really important point, as you grow, your skeleton grows. So think about when you were a toddler, okay? Your skeletons were quite small, and as you grow, your skeleton also grows as well. Okay, that's a really important thing to remember. And when you become an adult, that's when your skeletons stop growing. So that's the first one, endoskeletons, and these are vertebrates. Our skeletons, our bones are inside our bodies. Okay, maybe have a feel. Can you feel your bones? I can feel the bones in my fingers. Okay, I can't see them. I know they are inside my body. Okay, big bone up here. Okay, that's your skull inside. You can't see it, can you? So it's inside your body. So those are endoskeletons. Okay, here are some animals with exoskeletons. This means the skeleton is on the outside of their body. There's a little clip here. I'm hoping it's going to work. And exoskeletons, something to remember about them, they do not grow with the animal. So when the animal gets bigger, when the animal grows, they have to get rid of their old skeleton and make a new one to fit their body. Now, hopefully there's a little clip of what happens to a crab. Here it comes. Wow, so hopefully you were able to see there that as the crab grew, he had to get rid of its old skeleton and the new one was being produced underneath. Okay, but it makes the crab very in a very dangerous position, because when it's still a little bit soft, that's when a predator would want to come along and gobble it up, I'm afraid. Okay, so they do not grow with the animal. So when the animal grows, it needs to shed its old skeleton and produce a new one. Here are some examples of other animals which have exoskeletons. So lots of insects. Okay, so here you've got a grasshopper. If you were to be able to go up to that and actually tap the outside of it, it would feel hard. Here we've got a scorpion, a crab, and a stag beetle. And finally, our last group, again, remember these are, again, invertebrates. Animals with hydrostatic skeletons don't have any bones at all, okay, on the outside or the inside. They are very soft, jelly-like, squishy creatures. So all animals with hydrostatic skeletons are invertebrates, and instead they have a fluid-filled compartments in their body called a coelom. Okay, so there we've got a slug, a jellyfish, and a starfish. Imagine if you cut through that animal, okay? If you cut through it, it would be soft on the outside and there would be no bones inside that body either. So there's our 3 different types of skeleton: endoskeleton, exoskeleton, and hydrostatic skeleton. Okay, just pause for a moment, because in your activity, you're also going to have to do this. Can you think of an example of any other animals with exoskeletons, endoskeletons, or hydrostatic skeletons? Which other animals would go into those groups? Have a think. What would have an endoskeleton? What animals would have an exoskeleton? And which animals would have hydrostatic skeletons? Okay, so here's your activity today. This is on your daily post. So you've got a table here, and at the top it says endoskeleton, exoskeleton, hydrostatic skeleton, and these little pictures, all these different animals, you need to cut them out and then put them in the right place here. So if you were looking at the elephant, first of all, I think we've met him on these slides before. So an elephant, does he have an endoskeleton, an exoskeleton, or a hydrostatic skeleton? If you can cut those out and stick them on your sheet. Otherwise, just have a look and maybe write them in your books, which group they would go into. So an elephant, endoskeleton, exoskeleton, hydrostatic skeleton. So for each of those, see where it would go. There's a little bit of extra there for you to have a think about. Could you think about any other animals which would go into those groups? There are a couple here which are tricky, that make you think a little bit more deeply. Okay, so that's your first activity to do. So just pause the recording while you do that. And then when you've completed that, just a little bit more for you to think about. What are the pros and cons of the different skeleton types? That means what's good about them and what's bad about them. So what's good about an endoskeleton, but what's not so great about it? What's good about an exoskeleton and what's not so good? And what's good about a hydrostatic skeleton and what's not so good? And there are some ideas down here that would fit into each of those boxes. So which one grows with the body? Which one gives more protection? Which one does not grow with the body? Remember that crab little video. Which body do you think is the most flexible? Which one do you think would not be very good at lifting? And which one would have inflexible, not very flexible muscles? Okay, we're going to come on to think about muscles in the next couple of weeks as well. So just a few there for you to think about. Again, thinking a little bit more deeply. And then finally, if you want to do a little bit of extra reading, extra practice of vertebrates and invertebrates and different types of skeletons, there is a link to BBC Bite Size for some more activities, and there's a quiz on there as well. Okay, look after your skeletons, and I'll see you next time for science.